Hello, ladies and gentlemen. All right, so the biggest part of this unit is verifying, and we haven't officially verified anything yet because we've been trying to build our skills of simplifying, substituting, and in many ways, all the background algebra that comes into play in this unit. So, what you need to do right now is have page 8 open in your notes packet. All right. And we're going to go very quickly through some background skills or just things to be aware of when you're looking at an identity you need to verify. Okay? So, whenever you're given an equation, you want to pick the side that's more complicated. So, left-hand side, right-hand side. And you want to manipulate it. That means you want to do whatever math looks like it's asking you to do. For example, if you look at this, this is your left-hand side and this is your right-hand side. You want to pick the side that looks more complicated. All right, the side that maybe you could distribute or add things or whatever. I'd like to hope that in looking at these two sides, you would say that you think you might be able to do something with the left-hand side. All right, and that's the side you're going to start with. Okay, so that's the first thing. Pick a side. The first thing is pick the side you can change. That might actually help. All right, over here, you could change cosecant to sine, but that's not really going to help us all that much. It's not going to get us back to distribution. All right, second thing, anytime you can factor, do so. Okay, here are the three main types of factoring that you are going to see. You are going to see a difference of two squares. You are going to see a perfect square, or you might see a GCF. All right? See if you can figure out which type the problem on the right-hand side is. Again, just practicing our algebra behind the scenes. So see if you can figure out, this is one of these, a dots, perfect square, GCF. Pause this video, see if you can figure it out. I am hoping that you unpause this and before that you figured out this was a difference of two squares. Difference because you're looking at subtraction and two squared values. All right, so factors to sine theta plus cosecant and sine theta minus cosecant theta. So I used this format to help me get there. All right. Other thing you need to notice, if you see a term outside, you want to distribute it. Okay, so that is like taking A to B plus C, which would be AB plus AC. So try this distribution on your own and then simplify it if you can. All right? See you back here in a second. All right, welcome back. So hopefully at the very least you figured out that if you distribute sine, you're going to get sine times cosecant and sine times secant because those are the two terms in there. If you notice, I substituted cosecant and secant. The advantage here is that by doing that, I can cancel out a sine, so I'm left with 1. And I can rewrite this as sine over cosine, which ends up being tangent. All right? Remember, those are all on that reference sheet you have. So all of these reciprocal identities and quotient identities are there for you to practice substituting. All right? So that's distributing when you've got one term. Here, same idea, only a little bit more work is going to be involved because we are distributing one term and then a second term. All right, so we're looking at distributing sine and then cosine. All right, so see if you can figure out what that would look like and simplify it. Okay, unpause the video and come back and see what you get. All right, ladies and gents, so if you take a look, I distributed, so I got a total of 4 different terms. I tried to color code them so you could see the first 2 from the first distribution and the second 2 from the second distribution. Then anything that was a reciprocal function, cosecant, secant, cosecant, secant, I substituted. And then conveniently some things canceled, and then they would left me with 1. And then sine over cosine and cosine over sine, they don't reduce, but they can be written as one fraction, which can be rewritten as tangent and cotangent. So I could leave it like this and this. would be simplified. All right? Moving right along through these. Now, when things get a bit messier, like you have a fraction, for example. So this is a fraction, 1 over a plus b. If you can't do anything with this fraction, you can multiply it by its conjugate, a minus b. That'll work out really nicely. Only problem is you can't multiply by something just in the denominator. That doesn't work. You have to multiply by 1. The way you write 1, like I know this might seem weird. A minus b over a minus b is 1 because it would simplify. Don't try and cancel it out. That's not the purpose. If you multiply by it just to cancel, you just wasted your time. You're doing this so when you multiply, even though you made the numerator more complicated, what you did in the denominator was you took two factors and multiplied them together. And since the factors are conjugates, you should know that they give you a difference of 2 squares. And a difference of 2 squares is almost always going to have one trig function that you could use over another. So I want you to take a look at this fraction over here with sine in it and 1 plus cosine. What you would multiply by is the conjugate of the denominator. So it would be 1 minus cosine of theta, top and bottom, okay? And I want you to see if you can figure out what you'd get when you simplify that. All right, give it a try. All right, so stick with me on this explanation. Start by distributing. Only in a rare case where I don't, I left this unmultiplied. You can multiply it back out, but I think you're going to want to leave it like this. So then when you multiply this to get the difference of 2 squares, I replaced 1 with sine squared plus cosine squared because it is equal to that identity. And what's nice about that is the cosine squareds that are now both in the denominator cancel. So I'm left with sine squared, which instead I have the sine times something else, I can cancel with one of the signs in the numerator, in the denominator. So 1 in the numerator, 1 in the denominator of the 2 that were there. So I end up leaving this factor 1 minus cosine all by itself with a sine of theta underneath. All right? Pause that if you need to see that explanation or just write that down. Take some time to make sure that you feel good about that and that that makes sense. Okay? The most important thing is the idea of if you see 1 plus, if you see 1, you multiply by the conjugate, so now we're squared, which means we can substitute. All right? Okay, I think there's 2 more ideas that we need to address. The first of which is what happens when you have 2 fractions and you need a common denominator. So the gist is you take the denominator from one and you multiply that fraction by it. You take the denominator from the other, you multiply both top and bottom by that. So you get b and a, those are the denominators, over a times b. But you don't change the denominator after that. ab is ab. So to get you started over here, we would multiply this right-hand side, hopefully you could guess, by tangent of x, and we would multiply this left-hand side by cosine of x, top and bottom, okay? See if you can figure out what, if anything, might happen to simplify from here, all right? Or at the very least, just write out what those would look like as one fraction. All right, welcome back. So I multiplied by cosine on the left side and tangent on the right fraction. So I get cosine over cosine tangent, and I get tangent over cosine tangent. So then the 2 are in the numerator together, cosine plus tangent over cosine times tangent. Now, this actually simplifies quite a bit. I'm just going to show you one way that this could be slightly simplified. Tangent, I remember, has cosine in the denominator. Why does that matter? Well, if I rewrite tangent as sine over cosine, then I can cancel out my cosine, so I have one less term in the denominator. Now I could keep this going, but I just wanted you to get the gist of mainly putting 2 fractions together. So as long as you kind of understand that, or at least have seen that, that's the main focus of this problem. All right, so I believe this is our last skill. When all else fails, if you are totally stuck and you just don't know what to do, especially if there are too many types of functions, switch everything to sine and cosine. Every single ratio, secant, tangent, cosecant, cotangent, they can all be rewritten in terms of sine and cosine. So we're going to do that right now and see what happens, okay? So tangent is sine of theta over cosine of theta. Cotangent is cosine of theta over sine of theta. Secant is 1 over cosine. And cosecant is 1 over the sine of theta. All right? So what can I definitely do right off the bat? Well, anything that has a common denominator, so like this, with this guy, I can add those together. So sine of theta minus 1 over cosine. And then I can add this fraction with this fraction. So that would be cosine of theta minus 1 over the sine of theta. All right? Now I could leave it like that, but we just talked about adding fractions together. So let's talk about how we would add these together. You'd multiply by the sine on this side. You'd multiply by the cosine on this side. And don't forget that that means you're going to distribute. So I would end up with one big fraction that had sine and cosine as the denominator. And I'd end up with sine squared theta minus sine and cosine squared theta minus cosine. Well, these two, sine and cosine, that's really 1. All right, so really I have 1 minus sine of theta minus cosine of theta over sine of theta cosine of theta. All right, and that may or may not simplify a little bit further, but at the very least, we got it to all be 1 term instead of 4. All right, now you're probably at the point of thinking, what the heck is the purpose? Okay, here's the ultimate goal, all right? Here's the end game, if you will. You're going to be given a statement like sine of theta plus sine cotangent, and you're going to be told it is equal to something, all right? Your job is to prove that that's true. You got a left-hand side and you got a right-hand side. It doesn't matter so much which side you start on. What matters is you only deal with one side, and in many ways, you should deal with the messier side first. All right? In some ways, this is like a proof, but only in the sense that you can only take one step at a time. No skipping steps. So, the first thing I'm going to do is I'm going to tell you that we're going to pick the left-hand side. All right? And what we're going to do to that left-hand side first is we're going to take out a GCF. If you haven't looked closely yet, you should notice both terms have a sine of theta in them. So I could factor that out, and I'd get 1 plus the cotangent squared of theta. Now, this is equal to cosecant, hopefully. Now I'm going to look for one thing that I can do. Well, cotangent squared, that's cosecant squared. All right, we're getting warmer. Now at least I have cosecant, which I want in my answer, in my left-hand side. All right, remember, one thing at a time. Ooh, sine, that's 1 over cosecant of theta. All right, and this is cosecant squared over 1. I just rewrote that as a fraction so you could see that. Well, look at what I've got here. I've got 2 up here, 1 down there. I could cancel one of them out. So that means I'm left with cosecant of theta, which is what I wanted. So in your very last step, kind of like a proof, you want to write what you got and show that that is what I was supposed to get. And then I put a period, like this is the end of my proof, and 2 lines to be like, I'm done. That's just notation that we use in mathematical proofs at the end to say that I'm done. All right, I'm going to try and do this last one pretty quickly. So I want you to see if you can figure out which side to pick. And with the 20 seconds I have left in my video, I'm going to try and explain that. Here we go. So I took one thing at a time. I took the left-hand side. I picked tangent to switch first. It canceled out my cosines. I got 2 sines, so sine squared. And that is, if you think about this identity, if I move cosine over, that is equal